I hope all of us have understood what is this. How do we use the parallax method to find the distance between? Similar method we can also use to find the distance between sun and earth, or any star which is very far away from us, which is appearing to us as a dot only, a simple dot. So using this same method, parallax method, we can calculate what is the size of that particular planet or dot. Fine. Then this was for measuring the very large distances. Now how do we calculate very small distances? For example, the size of an atom. Okay, the size of an atom is very less, of the order of 10 to power minus 15 meters. Okay, and if we want to measure this distance, the what is the diameter of the atom? See, earlier we measured very large distance, which is nothing but the diameter of a planet or an object which is very far away. Now the object is very close to us. Okay, and we cannot use standard units, or for example meter. If we take 1 meter, then in 1 meter there will be many thousand and crore of molecules. So if we want to measure only one, what is the diameter of one molecule, it is very difficult. So what we do is, to measure the molecules, we sometimes try to use microscopes. Micro means small, scope means vision, or to be visible. So because these microscopes, they also have certain limits. That means they cannot measure values which are smaller than a certain value of their lens. So it depends upon lens properties, optical properties of a microscope. The second method of finding the values is nothing but using a very good microscope, which can even look at very small dot clearly, very clearly, or very small sizes of molecules. We try to measure using this microscope, which is known as electron microscope. Now these electron microscopes, actually they are very what you call sensitive and very costly, hugely costly. So we don't find these things easily in our labs. Also, you will not find these microscope in many institutions, school or colleges, because they are so much costly. Okay, then what we do is, we basically there is an example in the textbook of something called oleic acid, but we'll try to understand in a different manner. What do we do is, basically somehow we try to come up with a mono layer of molecules. Okay, mono means single, and layer means, everyone knows, layers of something, one over the other. So what we do is, somehow using a chemical reactions or chemical combination, we come up to form a mono layer. Mono layer means, so a single layer of molecules, right? So that means along one line there are only one molecule. This is called mono layer. Only single line of molecules are present. So using some chemical reactions, we try to find out a mono layer, and then we calculate the thickness of this layer. Okay, so T is nothing but the thickness of the layer, a single layered molecules. If you take a glass filled with a chemical, then there will be multiple layers of a molecule. There can be many layers. So what we can do is, somehow it is very difficult, also it is very difficult to get mono layer. It is not that easy as we think. A single layer of molecules are very thin, of the order of nanometers, or sometimes we say micrometers. So of the order of micrometers, that means 1,000 times less than millimeter, and 10,000 times smaller than the centimeter. That is how it is. So it is very small, very difficult to get. So somehow we calculate the thickness of this single layer of molecules, and let's say in this layer there are n number of molecules, could be 10, could be 100, could be 1,000. Okay, and could be 10,000. So all these molecules, n number of molecules are present. Fine. So if one molecule, and what we do is, this mono layer has certain volume, because molecules are present here, and because we are holding this mono layer at some plate, or maybe in some glass, So we know what is the volume of a glass. So with the help of a glass, we are able to measure what is their total volume, which is having n number of molecules. Fine. And because somehow we also calculate what is the surface area of the solution. What is the surface area? So if we put this monolayer on a sheet of a paper, not a paper, on a sheet of a plate or a metal plate or specialized equipment which is used to measure the thickness of this layer, we will also be able to calculate what is its the total surface area. So we know the total volume of this monolayer, and we also know what is the total surface area of this monolayer. And if you are good at mathematics, then you will be knowing, we know that volume is what? Volume is area into thickness or height of something. Okay, so we have the thickness or height, we have the volume and area. So if we divide the total volume of this entire solution with the total area of the solution, total volume divided by total area will end up getting this expression. Okay, and because we already know what is the volume and what is the surface area, we are actually not getting thickness from here, because our instrument cannot find the thickness of this particular layer, even less than nanometer actually, where our instruments do not work. So what we did is, somehow we formed a mono layer, and we calculated what will be the total volume of this layer and what is the total surface area of this layer. And assuming that there are n number of molecules, okay, we end up getting this formula which tells us thickness of one molecule, right? Because see, the diameter of all the molecules are same. All the molecules, if they are of same size, their thickness will be nothing but equal to their diameter. So this is how we calculate the diameter of very small, very tiny molecules when and wherever it is needed. So this is the second method of a second indirect method for calculating the distances or length. So we have seen what is direct method and what is indirect method. Okay. And then so we have seen what is direct method and what is indirect method. If anyone is having any doubt, they can directly ask me, and or they can message Ashok sir, so we can get back to your questions and solve your doubts. Then, like we have measured the length using two different method, we also use methods to measure the mass of an atom. Now imagine if the diameter of an atom is so small that if we cannot measure the mass of one atom using our weight balance tarazu, we cannot use it, because if we place it on the weight balance, it will be like it is not even there. Because our the weight balance or machines, they are made, or they are calibrated, they are designed to measure masses which are in grams or which are in kg, and not these tiny masses of atoms and molecules. Fine. So we cannot use kg, we cannot measure mass of atoms in kg. Instead, we use a different type of a unit which is known as unified atomic mass, denoted by U. The symbol of unified atomic mass is U. So we use this unit to measure the mass of an atom. Okay, and 1 unit of atomic mass is equals to 1 by 12 times mass of carbon 12 isotope. So in chemistry you would have studied there are many isotopes of a carbon, and because carbon 12 isotope is abundantly and generally available on earth's surface, what we try to do is we compare the size of an atom to the carbon 12 isotope. So this is an indirect method in which we are trying to find the mass of an object, which also includes the mass of each and every electron which is present inside it. So scientists find out, or people find out after calculation, that 1 unit of unified atomic mass. One unit unified atomic mass. For example, we have seen 1 second, 1 minute. So similarly, one unified atomic mass is equals to 1.66 into 10 to power minus 27. Okay, so that's all for today's class, and thank you very much all of you for paying attention. Okay, even if you see these videos later, try to refer your textbooks or online material so that you can we can get a better idea, and you can come up with any question you want. You can message me directly, or you can talk to Ashok sir. So thank you very much. Stay home and stay safe.